I appreciate everybody's attendance on today's webinar. My name is Jason Hall. I'm a senior solutions architect with Upsolver. I've spent the bulk of my career working with data in various forms, and I'm excited today to show you how Upsolver can help with database replication, and specifically on ingesting database data into a data lake and/or a database, a data warehouse. We've got a really big audience today, and I'm really excited to see that. And whenever we do get an audience like this, I do like to learn a little bit about who I'm speaking with. So I'm actually going to launch a poll. I'd appreciate if many folks could respond to that as possible. You should see that open up within Zoom. Really just looking to get a feel for what types of databases everyone's working with out there, from PostgreSQL to MySQL, Oracle, SQL Server, et cetera. And also what types of cloud infrastructures or maybe no cloud infrastructures that you might be working with. So I see a lot of responses to that coming in. I'll give it a few seconds here while I go over some logistics, and then I'll share the results with the full audience. A few logistical items about today's session. We are recording this session, so if anybody does have to drop early or wants to share the content with some of your coworkers or colleagues, we'll definitely make the recording available. We do have everyone's phone line muted. Thankfully, my phone line is now no longer muted, but we've done that for audio quality reasons. We do very much want to encourage interaction, though. So if anybody does have questions as we go through the content today, feel free to send those to the Q&A function of Zoom. You'll see a Q&A panel in the Zoom console. You can ask any and all questions as they pop up. I'll do my best to moderate that as we go through the content. And if there's something relevant towards what we're discussing at the time, I'll try to answer it in real time. Anything I don't get to during the session, though, I'll make sure that we answer at the end. I think we should have plenty of time after I wrap up my planned content to make sure that we can get any and all questions answered in the hour that we have today. So again, thanks for everyone answering that poll. Let me go ahead and end, and I'll share the results with everybody. It looks like a pretty wide range of databases, which is not unexpected. Pretty high volume of you out there are using, it looks like PostgreSQL, MariaDB, SQL Server, Oracle, a little bit of Mongo, and a fair amount of others. So that's kind of what I was expecting. No clear winner, other than it looks like SQL Server being the most used database platform out there, but a pretty even distribution of the rest. And then if we look at cloud platforms, looks like the majority of you running in AWS, Microsoft Azure, a relatively distant second, I'll put it that way. And then it looks like the what's actually kind of encouraging is that very few are running all of your databases on premises. This cloud migration has certainly been going on for years now, and it looks like that most of the audience in the webinar today has gone through at least some version of that. Right? So again, thank you for answering that poll. That's very helpful for providing some context on what we're going to be covering today. So I've introduced myself. I've gotten to know the audience a little bit. I'll introduce you to Upsolver for those that haven't come across our company before. Upsolver is a company that has a product that helps customers with high quality and reliable data ingestion into data lakes and data warehouses. In general, we're really trying to help customers work with complex data sources and provide them both simple and powerful mechanisms for ingesting that data into their data lake or data warehouse. You can see we carry many certifications and partnerships, and really over on the right, you'll see reference to the fact that we are both built and priced to handle very large scale data volumes. You can see that 20% of our customers are actually working with over a petabyte of data within the Upsolver platform, and 85% of our customers are working with more than 10 terabytes. So very much a strength of the platform, and something that our customers appreciate is how we make working with data at scale very easy for them. You can see some of our customers down at the bottom of the screen, but I'll just kind of highlight the fact that we have a wide range of customers, from startups to some of the largest enterprises in the world, and we work across a wide variety of verticals. So whichever industry you might find yourself in, be it healthcare, advertising, manufacturing, finance, there's a good chance if you're working with any of these complex data sources that we can help you provide, again, high quality and reliable data ingestion. Now, I mentioned one of the core value propositions to Upsolver is this simplicity in which we can help customers work with complex data. And again, the purpose of today's session is to talk about CDC, or change data capture, in allowing customers to ingest and replicate database tables into their data lakes or data warehouses. So I figured if we're going to be talking so much about simplicity, what better way to show that to you than to actually demo the simplest possible way to ingest data into a data warehouse from a relational database system. And we titled this in 10 minutes or less. So if anybody wants to get your stopwatch out, feel free. I'm hoping we can get it done in 10 minutes. I'll explain a few things as we go through, which might lengthen the process a little bit, but let's go ahead. I'll share out my screen here and we'll get right into the product so you can see how we can make it very easy to work with change data, capture data from a relational database. I'm going to go through this exercise today in Postgres. We're looking at the Upsolver interface here, and you'll see we can get started with ingestion wizards. And these wizards provide a very simple no-code experience to ingesting CDC data into your data warehouse. The wizard starts by connecting to your source data. I've already got a Postgres connection here that I'm going to work with. If I didn't, I could very easily create one. And I'm going to point to a publication that's been configured that we're going to read CDC data from. And you'll see we can also select the schemas, tables, and columns that we want to ingest into our data warehouse. For the simple use case, I'm just going to pick a handful of tables that I want to ingest. On the next screen here, I'm now going to connect to my data warehouse. So I already have a Snowflake connection created, but again, if I didn't, I could very easily create one. And I will map my Postgres tables to a particular Snowflake schema. And I'm going to give these tables a prefix, just so they're a little bit easier to find later in the demo. I'll call these webinar _PG_, so that all of my source tables will have this prefix in my Snowflake data warehouse. The last screen of the wizard here effectively answers how often do I, or allows me to configure how often do I want the data warehouse updated. The default is in near real time, so I'll follow suit here. I'm going to give my job a name. I'll update Snowflake once a minute, and I will delete rows that are deleted in the source. Here you can see some syntax that I'll actually go through later in the session for more of a low-code experience and those that might want to see kind of what happens behind the scenes. But for now, I'm just going to go ahead and run the CDC pipeline to ingest data into Snowflake. Okay. You can see the job was created successfully, and there's a button here that we can now click to launch into our monitoring interface to track the status of the CDC ingestion job. Okay. Now, for the first few minutes of ingestion, there's an initial synchronization that's going to happen between the PostgreSQL database and our Snowflake data warehouse. We're going to take a snapshot of each of the tables that were included in this pipeline. To start, the tables are listed in a pending status, and these will change from pending to snapshotting. And then when the snapshot's complete, they will change from snapshotting to streaming. And that's an indication that the snapshot's complete. And now we are streaming changes from PostgreSQL into our Snowflake data warehouse. If we look at the details of the job that's running while we wait for those snapshots to finish, here you can see the syntax that defines how we're ingesting data from Postgres, again, into our data warehouse. And for the most part, you'll see the syntax here very straightforward. Right? We give the job a name. We define the publication that we're going to read from on the PostgreSQL side, and we include a list of tables which we're going to be ingesting into our data warehouse. All right, now the example that I'm going through here, I just selected 2 tables, and you can see that Upsolver built a regular expression that defines that table list, but we do also allow users to define their own regular expressions to include a dynamic list of tables to be ingested into their warehouse. And we'll show maybe a more interesting example of that later in the webinar. But you can see here, again, the table include list defined as a regular expression to allow us to dynamically select which tables we want to ingest into our warehouse. So after we've kind of gone through that syntax, you can see actually one of our tables, we've already completed the snapshot. It's changed to the streaming status. The other table, we're getting ready to snapshot, and within a minute or so, we should see that also in the streaming status. So a lot of what we talk about in terms of Upsolver's value proposition is around providing observability into not just the quality of your data, but also the quality of your ingestion pipeline. And this is one example of that. Now, if I scroll down in this monitoring interface, you can see some helpful metrics. It tells us how many rows we've written as a part of this pipeline. Can also allow us to do debugging and tuning and really analysis on the throughput that our pipeline's able to process. We can track delay graphs to make sure that our source and target tables are up to basically real time, or if there is a delay, what that delay is. And then we also have kind of error processing and error handling, all very easily available and visible to the users that are managing and operating these pipelines. So this is the initial kind of input job of this pipeline that's going to read data from PostgreSQL into Upsolver itself. And then as a second part of this pipeline, we also have this output step. All right, so you can see that's the last job down here in the list labeled webinar output. And this is the job that's going to be writing the results of those streaming changes into our data warehouse, right? And in our case, Snowflake. Right, so we have the one table where the snapshot was complete. You can see that's currently in a streaming state. It's up to date with no delay. Momentarily, if not on the next refresh, we should see that second table show up in the output job. Effectively, now we're writing data into the Snowflake data warehouse. And if I switch over to Snowflake itself, just so you can kind of see the results, here's the schema that I was writing data into. Don't worry about these PG tables. That's for a different use case that I'll highlight later. But if I refresh my Snowflake schema, sure enough, you can see the webinar currency table. That's the first table where the snapshot is complete and we're now streaming changes on. Let me just change this table. And you can see, sure enough, we should have data available. Yep, so we can see the results of that table that we've replicated from Postgres into Snowflake. So I didn't actually take a specific note of the timestamp, but I believe that was about 6 or 7 minutes or so when we were able to ingest data, production quality data from a PostgreSQL database into our Snowflake data warehouse. I'm going to show you a lot about kind of what's happening behind the scenes here as I go through the rest of the webinar, but again, wanted to start by kind of highlighting just the simplest way to get CDC data from a source database into our Snowflake data warehouse. Now, a little bit more kind of about what's happening. All right, so here's kind of a high-level architecture discussion on the ingestion service that Upsolver provides. Okay. Over on the left-hand side of the screen, you can see reference to the complex data sources that we work with. Right, and if I'll just highlight them, we can read data from streams, be it Kafka or Kinesis streams. We can read files of a variety of formats that are sitting in object stores, for example, Amazon S3. And what we're talking about today, reading CDC logs from operational databases. Right. I see a question come through. How are we reading data from databases? So it's dependent a bit on the database itself, but for the purpose of Postgres, we're using logical replication. Postgres has a configuration that can enable logical replication. That allows Postgres to maintain a log of transactional records that have been applied to a set of tables that are included in the publication. And then Upsolver reads from that log to process those events. And again, we do an initial snapshot of data, and then we process those transactional events to apply inserts, updates, and deletes to each of the target tables as they're streamed into the Upsolver platform. So it's logical replication, and we're using, again, transactional replication from the source systems. So we read data from operational databases, and then we bring them into into Upsolver, where a few things happen just by design, right? These aren't really things we had to configure or even think about, but they happen internally to the Upsolver platform. You've already seen, for example, that 10-minute setup with very minimal interaction needed to build out an ingestion pipeline. We built out that pipeline through our wizard-based UI. And again, for those very simple use cases where you want a kind of a no-code experience to read from a source database and write into a data warehouse, that wizard may be sufficient for a variety of your tasks. But you did see kind of a snippet of SQL that wizard generated. And you do have full ability to configure your own SQL to build out your ingestion pipelines as well. And we'll take a look at some additional examples of that later in the webinar. So we've got both a UI as well as a SQL-based experience for building out CDC-based ingestion pipelines. And the SQL that we create can be run through the Upsolver UI, but can also be run in whatever your development environment of choice is. Upsolver does provide a DBT connector for those of you that are doing data modeling and data transformation using DBT. You may decide to add Upsolver ingestion processes to your DBT models, right? Maybe step one of your model is to ingest data from PostgreSQL and replicate it into Snowflake. And then you're going to take that data that's in Snowflake and model it and transform it further with DBT, right? The DBT connector to Upsolver allows you to do that. Upsolver also has a CLI. So you can run Upsolver SQL through the CLI and really incorporate into any batch processing that you might want to perform. And then we also have a Python SDK for those that are developing in Python and want to add Upsolver commands into their Python scripts. We provide that as well. So really a lot of flexibility to build out your ingestion pipelines. We like to say kind of use your tool of choice, whether that's our no-code wizard experience, our low-code SQL experience, or you can add Upsolver to DBT or CLI or a Python SDK. Now, the exact sync reference here is some technology that we provide that guarantees strong ordering of data as it's streamed through our ingestion pipeline. Now, that may seem obvious, and I've talked to some customers about ordering and how big of an issue it is, and some of the feedback I get, well, isn't data ordered by default? And in some cases it is, but there are lots of scenarios where ordering of may not be guaranteed, especially in multi-partitioned environments. There's some known challenges when reading from Kafka, which a lot of CDC providers actually take advantage of, where if you have multiple Kafka partitions, there's no guaranteed ordering of events between those partitions. And that can be really difficult to work with, especially with CDC data, right? Because in a CDC scenario, every transaction is going to be dependent on the transaction that happens prior to it in order, right? You can't delete a record if it doesn't exist yet, right? So if an insert and a delete happen out of order, your data is going to be out of sync. So the way that Upsolver handles all of its ingestion pipelines, whether you're reading from Kafka natively or, for example, from an operational database like Postgres, is that we guarantee strong ordering events at scale, even in multi-partitioned environments. Schema management is something that Upsolver handles automatically. And I'll show you several examples of this because this is a real strength of how Upsolver handles CDC especially. As the schema evolves on your source systems, and these could be new tables that get added to the database, or new schemas that get added, or even new columns that get added to existing tables, your pipelines adapt and continue running and continue ingesting even when those schema changes occur. This is something that I know a lot of data engineers really struggle with, is that the schema changes on a source system, and at best, your pipeline doesn't incorporate the change schema. At worst, the pipeline breaks altogether, and you've got to go back and manually correct something that happened so that the pipeline can continue operating when that schema changed. So we handle various forms of schema evolution natively and automatically inside of the platform, right? And then finally, we provide real-time observability into the quality of the data that's being ingested, as well as the health and reliability of the ingestion pipeline itself. All right, we showed you a few examples of that already, and I'll show you more of that as we get into the demo. All right. So again, all of these things that you see here in terms of what's happening behind the scenes in that ingestion pipeline are just native to the platform. Right? We step through 3 screens and a no-code wizard, and you're just going to get everything that you see here on the slide as a part of that ingestion process. Right. And just to highlight that in a little bit more detail on the next slide, I have effectively, if you think about all the different steps of an ingestion pipeline, from extracting, loading, transforming, and then eventually operating the pipeline long term, these are all the things that Upsolver is not going to require our data engineers or end users to have to honestly even think about, let alone code for and build practices around, right? Managing Kafka consumers, managing AWS DMS, adapting to schema evolution. A lot of our customers are using platforms like Snowpipe to handle Snowflake ingestion, and Snowpipe can be very difficult to tune and get right in terms of managing file sizes. Coding for deduplication, strong ordering of events, scripting out, what do we do if a new table gets added to a Postgres system, right? All of these bullets are things that data engineers have traditionally had to worry about in their ingestion processes and maybe code around or build practices around. And these sorts of things are what you get just natively with Upsolver. So let's go take a look at a bit of a deeper dive into the demo, and I'll show you a few other things that I think are important to comment on in terms of how Upsolver handles ingestion pipelines. You can see, as you imagine, we've given another few minutes now. Both of my tables are being replicated in my output job, and if we go into Snowflake, we'll see the second table show up there as well. Right. So let me clear out my annotations here. Sorry, annotate, clear all. There we go. And I'm going to jump back into that wizard. And now that I'm not on the clock anymore, I'll spend a little bit more time explaining what's happening as a part of this ingestion process. Right? So when we connect to our source system, again, we're connecting to Postgres and we're reading from a publication. Right? This publication is defined in Postgres itself. And the publication definition will either include all Postgres tables, or a database administrator can select which tables are included in that publication. By the way, these wizards have built-in documentation over on the right that walk you through all of the different prerequisites that need to be set up prior to configuring this wizard. So if you're unfamiliar with that publication concept, the documentation will guide you along that process in getting that configured. There's a heartbeat option here. This is optional, but it's a really nice capability because there are known challenges with database CDC, where if there are no transactions to be replicated, the CDC can break or go stale. I've heard it referred to both. And the replication slots on the target side can actually cause inconsistency and corruption, and can even cause systems to crash, right? So what this heartbeat allows you to do is force a transaction into the database once per minute so that there's always at least one transaction to replicate into Upsolver, right? If your system is very busy and you never have to worry about a replication going stale for long periods of time, this is probably redundant, but this is a nice option, especially if your workloads are sporadic and you want to force a single transaction to be replicated on a given frequency. Here you can see the schema mapping. Right. So in the first example, I actually hand selected just two tables, but you'll notice there's checkboxes here that we can use to define the schema that we're going to be ingesting into our pipeline. And at every level, you'll see this automatic option, right? So the default behavior here is to replicate everything, right? And there's lots of use cases where that's exactly what you want to do. You want to take every schema, every table, and every column from PostgreSQL, including schemas, tables, and columns that get added after we create our pipeline, and have those all replicated into our data warehouse, right? And that's the default behavior here. Just leave everything selected, including these automatic options, which allow us to adapt to schema evolution. If you don't want to ingest everything, though, you can define, for example, a single schema that we want to ingest, but everything within that schema. Or you can define a selected set of tables, but again, within those tables, you can select whether or not you want new columns to be ingested into your pipelines. Right? There was a question that came up in the Q&A about potentially sensitive data. And I'll go through a few examples on how you might want to deal with sensitive data like PII, but one option is to simply redact it. Right. So I might want this credit card table to be ingested into my data warehouse, but I don't want the card number and I don't want the expiration month and year. Right. We can deselect those columns. We'll still have the metadata fields, but I won't have the PII ingested into my warehouse. So that's probably the simplest way to handle PII. Just simply don't write it into the data warehouse through redaction. But I'll show you a couple other options later in the webinar. But again, notice if a new column gets added to this table, it will automatically be ingested without any need to modify the pipeline itself. So we can go through this schema selection dialog. You can also, I alluded to this earlier, this is where you can use the regular expression option if you want to dynamically build out a list of table schemas and columns to be ingested through the pipeline. You can provide us with the regex and we'll just use that regex, right? The other option is to use the selections here. On the next screen, again, we're going to select our Snowflake target that we're going to be replicating data to. This is where you can select the schema that you want to write data into and possibly give a prefix to the table name. You don't have to prefix the tables, by the way. The default is just create a table in the Snowflake schema of the same name as the Postgres schema. And if that's what you want, that's the default. You also have this ability down at the bottom to add various mappings of different Postgres tables to different Snowflake schemas. All right, we've seen this oftentimes where either in a multi-tenant environment, you might have different Postgres schemas and you want to write tables from each schema into a separate Snowflake data warehouse. So that's an option here where you can add any number of source and target schema mappings that you want for each of the tables that are being replicated. And then if we keep going in the wizard, we talked earlier about how often we want our targets to be updated. We can define whatever the frequency that we want to be. Given that we're writing data into Snowflake, you might be cost conscious of how often that Snowflake compute warehouse is running. So you might decide, let's stream changes in real time, but let's only write them to Snowflake once an hour or once a day, whatever our requirements are for data freshness on the Snowflake side. You will see an option here to define how you want deletes to be handled. We can do either hard deletes or soft deletes as a part of the CDC pipeline. For those unfamiliar with the concept, a hard delete is where if a record was deleted in Postgres, it's also deleted in the data warehouse. A soft delete would be if a record is deleted in Postgres, don't delete it in the data warehouse, but mark it as deleted. We often see this, especially in auditing or security type use cases where you might want those deleted records to be maintained in the warehouse so that we can report off of them even if they've been deleted from the source. So we do allow you to very simply set up those soft deletes and then just define what the column is that the soft delete flag is going to be recognized in Snowflake. And over here, you'll see reference to an event time column. This is the ingestion timestamp that we inject into each record by default. You can turn it off if you don't want it, but this gets really helpful, especially if you define aggregations or incremental transformation models in your data warehouse. You'll have an incrementing timestamp that basically shows exactly the timestamp of when data was ingested into your warehouse by Upsolver. So if you want to do aggregations or incremental models on only the records that have been changed during a given window, that timestamp field will allow you to do that on the Snowflake side. I see a couple questions. It's actually the Q&A is pretty busy, so I apologize if I haven't gotten to your questions yet. But again, we should have time at the end where I can rattle through all of them. One question that did come up was about the heartbeat and what type of transaction is it? It's just a simple update to a table that you define. So there's a table that you create. It's got two columns to it. One of them is a timestamp, and we basically update the timestamp with a new heartbeat. So just really updating one row into a specific table. You really shouldn't need to ever worry about the table or do anything with it. It's just a single row and a single table. And it doesn't have to be in the same schema of the tables that you're replicating. And again, it's optional. So if you don't want to use the heartbeat, as long as you're confident that you're getting a reasonable volume of transactions and you won't have long delay, long time ranges where no data is being replicated, then honestly, the heartbeat is probably not necessary. All right, cool. So again, if we step through this wizard and get to the code, you can see the code that's generated. And I'm going to exit out of this wizard for now because I already have the code in an existing worksheet. But you can see, again, the wizard will generate code for you. The code defines the 3 steps in a CDC ingestion pipeline. You can copy this code and save it to a local file if you want to run this through GitHub or work with this code through a Python SDK or a CLI, or incorporate this code into like a DBT model. But if I jump into the worksheet here, you can see the 3 steps of this ingestion pipeline. The first step are to create a staging area in our managed data lake to store the raw data. You can set whatever data retention you want on that staging data. We default to 7 days, but that's customizable. The second step is the ingestion job, which reads data from PostgreSQL in this case into that staging table. Again, with the table include list here dynamically generated to adapt to schema evolution. And then you have an output job here that writes data into Snowflake. And the default behavior here is to simply add the prefix that you define to the table name. But other than that, you'll see a select star reference. So basically take all of the source columns and write them into Snowflake as is. And because we're doing soft deletes here, we're also defining the delete key here to basically update based on our delete configuration. So this is that job that's going to take the raw data from Upsolver and write that into Snowflake. Now, as this is all running, right? So this ingestion pipeline is now running. We talked about the monitoring interface for looking at the pipeline itself, right? Tracking both the input and output jobs. But we also give you observability into the quality of data that's being ingested. For example, if I go back into that worksheet, you'll see a connection catalog down the left-hand side of the screen here, and you'll see reference to the Snowflake data warehouse that we're writing data into. And if I scroll down to the schema that I'm writing data into, you will now see tables, and these are the tables that I'm ingesting data using Upsolver into on the Snowflake side. And for example, the 2 webinar tables here, these are the 2 tables that we set up about 20 minutes ago at this point. Now, if I click on any of these tables, I get this card of information that I can bring into full screen here that's going to give me statistics about the data that's being ingested into that table. So for each table, we have a list of columns, the data type of that column, the density. So in other words, how often are non-null values in that column. This data is all 100%, so that means there are no nulls. We can see what some of our top values are, how many distinct values we've seen, and when we first and last saw a non-null value in that source table. So again, if maybe all of a sudden a column within a Postgres table we started seeing nulls where we don't normally, you would see the exact timestamp of when we saw a not null value in that particular table. Right? And now I've been ingesting this data for about 20 minutes now. We have not had any schema evolution, but what's really nice is if the schema does evolve, we will see that new column get added to this table. And if we scroll to the right, the first seen timestamp will show us the exact point in time that we saw the first value within that particular column. So not only will the pipeline adjust and handle schema evolution of new columns being added, but it will also give you the exact point in time of when that occurred. So if you do need to go back and revisit any ingestion logic or any transformation logic or notify some downstream team that a new column has become available, you'll know exactly when that's the case. One thing we also adapt to are things like data type changes. This is less common in databases because honestly, it's pretty hard to change the data type of a Postgres column, especially if the existing values don't convert easily. But it can happen. And so if that does happen, you'll also see reference to when those schema changes occurred. If, for example, the original column was a string or was a number and we changed the schema to be a string, you'll see the new column arrive of the new data type and exactly when that started to occur using these timestamp metrics. Now, beyond the table of statistics here, we also do have column level statistics. So if you want to dig a little bit deeper into a particular column, we can click on any column in our Snowflake table. And again, see how many values we've seen, how dense it is, how many distinct values, and what is the distribution of data within that Snowflake table. So this can be really helpful as these ingestion pipelines are processing and you want to inspect and observe the quality of the data that's being ingested into your Snowflake data warehouse. You're going to have these statistics automatically generated for you and available within the Upsolver UI. Now, there's one other use case I wanted to highlight, and this actually goes back to a question that I saw in the queue about PII. And I talked about one way that you can handle PII is to simply exclude them from your ingestion. You know, if you've got a credit card number or social security number, you can just simply exclude that from being replicated into Snowflake. But what if you do want to include the data? You just want it to be masked or hashed in some way so that the PII is not recognizable by someone who might have access to the warehouse. So that's where a use case here, where in addition to doing raw data ingestion from, again, Postgres to Snowflake, we can also apply transformation logic to the ingested data. And these transformations will apply in flight as data is being ingested into Snowflake. Here's a very basic example where I've created, now this is going to be a data lake table. I'm not writing this into Snowflake, but I just as easily could. But just to show you how it would work in a data lake context, I've created a table here in my data lake to store the credit card table. All right, so this is going to be a replica of our credit card table from Postgres. But here you can see a job that's going to create that replica of the Postgres table. But you'll see here, using these let commands that I've configured, we're actually masking part of the credit card number, right? And really just three functions here. I could have done this inline, but for readability, I've basically taken the last 4 digits of the credit card number and the first 4 digits of the credit card number and replaced everything else with X's, right? So you'd probably want to do something a little more advanced if this was a credit card number, but I just wanted to show a basic example here. So what this does is it writes every row from the source into the target. There's a select star here, except we're masking the credit card number using these string functions. And we're writing that into our data lake table. Okay. And if we look at that table here, I'll go into Snowflake here real quick and I'll show you the credit card table as it exists in Snowflake. Remember, this is a raw data ingest. So we can see these credit cards here that we've been added in, and sure enough, the credit card number is in plain text, easy for anyone to see. But if I go and look at my data lake table where I'm performing this transformation on the data, you'll see that that data is in its transformed format, right? So here are those same credit card IDs that you saw, Dave's bank and Jason's bank, but you'll see the hash or the masking that I've applied to that data as it's being ingested. So this is just one example. We have hashing functions that you can use like MD5 hashes. You could apply your own custom string functions to parse out and then reprocess that data if you'd like. But that's another fairly common way that customers might handle PII during their ingestion pipelines, whether it's coming from a database or really any data source, is to simply apply those transformations as that data is getting loaded into your data lake or your data warehouse, and know that that PII is being protected based on your transformation logic. So that's effectively the use case that I wanted to show here when it comes to working with CDC data in Upsolver, and both kind of the simplest way to get production quality data from a database into a data lake or data warehouse using our ingestion wizard, but then also the power that you get by working with SQL and maybe applying transformation logic to that ingestion process. All while natively handling schema evolution and while providing observability into the health of your ingestion pipeline, into the quality of data that's being ingested. So let me go ahead and look through some of these questions. Feel free to keep sending them. So there was a question about where we're getting data from, and I think I answered that earlier. This is log-based replication using a publication that exists on the source system. Depending on the source system itself, there's a process for configuring that log replication, but that's where we read data from. There was a question about our use of Debezium. We are using the Debezium engine to collect and process these log records. We do not, though, use full end-to-end Debezium. Full end-to-end Debezium is an open source platform that uses Kafka under the covers to process CDC from various sources of the targets. We use the Debezium engine to collect database changes, but we process them ourselves through our own proprietary technology. So there are some components of Debezium here. And that's really honestly a good thing. Debezium is very battle tested, works really well for collecting change events, but we think our technology to process and then apply those events within our pipelines is very unique to what we do. All right, we answered the question about sensitive data. So question about, are logs available in SQL? I may need that question clarified. If the question is about Microsoft SQL Server, we don't currently support Microsoft SQL Server, although we have imminent plans to support it. So stay tuned. Those of you that do want to perform CDC against a SQL Server database, very much it's in our short-term plans to support that. Stay tuned. Should be hopefully in a matter of weeks. We're going to be looking to offer that within the Upsolver platform. If the question is about, can you see the CDC events with SQL, then the answer is also yes. And that's actually part of our observability. I didn't touch on this, but that staging table that we talked about earlier, right, this first step in the ingestion pipeline is a data lake table. You may not care about it or ever need to use it as such, but that is what it is. So if you did need to look into the hierarchy of transactions that we've ingested, we have all of that raw data that's fully accessible to you. And it's accessible to you either through the statistics that we show in the UI. For example, I can click on the staging table. And if you remember the statistics that I showed you for our Snowflake tables, we have those same statistics here for our staging table in our data lake. Right? For each column, we have the density of that column and when we first saw it and when we last saw it and the data types and our top values. We also, if you scroll into that staging table, we have system columns. And these are the system columns that tell Upsolver how to handle and process those transactions. For example, we have the operation, right? Was it an insert, an update, a delete, or a snapshot? We have the primary key that transaction references. We have a Boolean field on whether it was a delete or not. We have the table name that the transaction affected, right? So all these system columns are what we use to process these transactions through our pipelines, and you can use them yourself as well. I had a customer who was looking at using Upsolver, specifically these staging tables, because they wanted to see the lineage or the history of a single row and how it came to be in a CDC pipeline. Right, so they could just do a select star from the staging table where the primary key equals its value, and it showed the snapshot, the insert, the update, the delete, really the entire kind of history of how that primary key value came to be within our CDC use case. So again, that question about are logs available in SQL, a couple of different ways I can answer that. If it's about SQL Server, very soon. If it's about accessing our CDC logs with the SQL, then absolutely just by querying the staging table here. Does the ingestion into Snowflake use JDBC or Snowpipe? We are not using Snowpipe under the covers. Snowpipe has some pretty significant limitations that make it very difficult to use for CDC use cases. So we're using our own technology to process these, process the CDC ingestion processes, and then we use a JDBC connection into Snowflake to apply, copy into the basically copy into and merge the results of our CDC ingestion into the Snowflake data warehouse. So there's no requirement for Snowpipe here. It's a good question about once CDC is enabled in the source, are there any if there are DDL changes, how does that affect jobs in Upsolver, right? So we kind of implied that when talking about schema evolution. So I may have already answered the question, but just to hammer home the point and clarify it, we automatically adapt our ingestion pipelines to handle DDL changes on the source. Right? So as long as your pipeline is set up to accommodate schema evolution, for example, you've taken advantage of those checkboxes that you might remember me setting during the ingestion wizard to automatically add new tables, automatically add new columns, things like that, then your pipeline will just simply operate and ingest those new columns and new tables as a part of our processing. Right? So schema changes really shouldn't break your pipelines, yeah, really, it's just a matter of kind of how we natively operate. There was a question about cloud environments. So Upsolver runs currently in AWS. It's a platform that you would deploy into your AWS infrastructure to process your ingestion pipelines. We are currently planning on offering a fully SaaS version of Upsolver. We have a SaaS version that's actually available for evaluations right now, but it's not available for production use. That is in our plans to offer that in the future. So if you're not an AWS customer, but might consider using a SaaS platform for this type of CDC, let us know that. We can keep you posted on when that might be available, and that could give you an option for running Upsolver without needing an AWS environment to deploy into. There was a question about lob and blob data replication. It's not a simple answer, and it depends specifically on the database platform itself that we're replicating from. But specifically, if those types of transactions are recorded to the wall logs, write-ahead logs in the database itself, we should have no problem ingesting them. So it's really more a question for the database platform itself and whether logical replication in that platform handles those particular data types. But in most cases, we shouldn't have an issue. There's a question about, can we replicate the exact data, or can Upsolver pre-aggregate or transform the data prior to ingesting? So the last use case that I showed around masking those credit card numbers, that's an example of a transformation prior to ingestion. But you could do really any type of transformation that you can define through SQL, right? If I go back into the Upsolver, one of the beauties of our transformation language is it's SQL, right? So in this example, it was a very simple select statement where really the only real meat to it here is the string functions that mask the credit card number. But I could just as easily put a group by on this, right? A group by with some aggregate logic to do some aggregation on the ingested data. Or I could do column filtering or column transformations. Or I could put a where clause on if I want to filter out certain types of records. So really the Upsolver, if you did want to transform data in addition to ingesting raw data, but also, or instead of, you want to transform data prior to it's being loaded into a data lake or data warehouse, it's just a matter of defining a SQL-based transformation with group bys, where clauses, column projections, and then have that apply in your output jobs in the CDC workflow. Let me continue here. Sorry, I'm reading through these questions, so bear with me while I look through some of the last questions that we have. There's a question around defining a replication using merges on a set of primary keys. That is the default behavior on how our CDC-based replication works. If you actually look at the syntax here, and I'll scroll up to this raw data, this is the syntax that defines how data is being ingested into Snowflake. And you can see the syntax references a merge ingestion, and it's merging on primary keys. So the logic here is we're merging into a Snowflake table, and the merge is on the primary key, basically saying the primary key from Postgres needs to match the primary key in Snowflake. If it does, then basically, well, the line 32 here basically says if the primary key matches and the row was deleted, then delete it from Snowflake. That's that hard delete use case. This basically says if the primary key from the source matches the primary key in Snowflake, then replace the record or update it. And then the last line here basically says if there is no primary key in Snowflake, for example, it's a new record in Postgres, then insert that data. So that's the way the replication's working on the Snowflake side. It's merging the Postgres table with the Snowflake table based on your primary key definition. And you can customize this as you would see fit, but for most replication or CDC use cases, you would want this effectively as is. The primary key from your source system would need to match the primary key in your target system. There's a question about when I say Upsolver data lake, where is this data lake created? So the Upsolver data lake is deployed in an AWS account. It's basically managed S3 data with a AWS Glue data catalog to describe and create queryable S3 data lakes within an AWS account. So it's all within the AWS VPC that Upsolver is deployed to. That's an important deployment consideration with Upsolver. When you deploy Upsolver, you're deploying it into your AWS VPC. And the S3 data, that data lake that we're talking about, is in your AWS VPC, meaning that it's as secure as you configure it to be, right? You can encrypt data using your AWS keys. You can set up security groups and firewalls to protect that data. None of your potentially sensitive company's data will leave your VPC, assuming you've configured it as such. So it's a good question. I'm glad you clarified that. When I did say Upsolver data lake, I wasn't implying a data lake on Upsolver servers. It's a managed data lake that Upsolver manages for you, but in your AWS account. There's a question about, is it possible to stream and merge data from multiple sources into a single destination? Absolutely. And that's actually a use case that I'm working with a customer on as we speak. It's specifically a MySQL use case, but they have 3 different MySQL databases. I believe they're regional, if I'm not mistaken. One of them in North America, one of them in Europe, and one of them in Asia, but they all contain very similar types of data. And they have a pipeline where they want to replicate tables from all 3 of those MySQL databases into a single Snowflake table, or sorry, single Snowflake schema. The only thing you have to take a consideration of there are table name conflicts. And for example, if the tables are all named the same, then you may need to separate those out if your primary keys are not unique between each table. If you've already taken care of that, it might not be an issue, but it's just something to consider. But the core use case of taking multiple database sources and ingesting them into a single data lake or data warehouse, absolutely, it's something that we do quite often with our customers. There's been a couple questions here about converting syntax between databases and data warehouses. For example, a store procedure that you might run on MySQL, converting that into a store procedure that you would run on Snowflake. That's not really what we do. That's more of a data modeling or code conversion use case. We'll certainly handle ingesting the data from source to target, but the code or programmability on top of that target is not something that Upsolver does. Okay. There's a question about for CDC pipelines, do we use primary keys as partition keys? We don't have to. You can. You probably wouldn't. But our default partitioning on our Upsolver data lake is by the table that's being replicated. So you'll have one partition for each table. And then you can also define partitioning by the date. So basically, that's kind of our default partitioning within our data lake, but you could define this to be partitioned however you'd like, based, and generally speaking, really it's based on the use case and based on the cardinality of those partition keys will define how you might want to partition. All right. There's a couple very specific questions that I don't think are going to be overly useful for the whole audience to hear. So I will answer those in the Q&A after we wrap up. If you've asked a question that I haven't gotten to, you might just want to stay on the line for a few minutes and I'll try to type out answers to those in Zoom. If we don't get to your question, it's not because I couldn't answer it. It's probably just because I missed it. There were a lot of questions that came through, and there is the chance that I missed something. I think, you know what, this is a good question I can answer to everyone. There was a question about how do we handle ingestion from on-premises systems? And specifically, does it work well? And I would say absolutely. Assuming it's an on-prem system that we support, like a MySQL database or a Postgres database running on your system, there's obviously a network bandwidth consideration there. But assuming a logical publication can be configured on that source system, wherever it is, and we can connect to it, you can, for example, there's a connection path from Upsolver running in your AWS account to wherever that system is. Then we should be able to ingest it just fine. And that's actually a use case that I have seen some customers take advantage of with Upsolver. They're in the process of migrating some of their on-prem data into Snowflake, and they might use CDC as a mechanism for doing that. So I think I've answered again. If I didn't get to a question, feel free to stick around. I'll do my best to answer it in the minutes that we have after we wrap up. But I will just leave everyone with the fact that we do offer a free trial that runs in our SaaS cloud. So for those customers that might want to play around with Upsolver and get familiar with the entirety of the product, including the CDC use cases that I showed you today, I would certainly encourage you to do so. We don't require a lot of information to run those trials, just an email address and a password, and that'll get you into the platform. Trial will run for 30 days. You get full access to the product and can try out pipelines using our own cloud infrastructure. If you want to take and deploy Upsolver into your VPC as a part of that evaluation, there's a simple process for that requires basically generating a CloudFormation template and then running that in your AWS account, and then Upsolver will be running in your VPC. And if anybody wants any assistance with that or needs any, would like to discuss further, when you leave the meeting here today, there will be a quick survey that pops up, really just gauging how useful you found the content, but also for anyone that might like assistance in setting Upsolver up to run their own evaluation. If you answer that question and give us an email address to reach out, we'd love to reach out and work with you further. So I appreciate everyone's time today. We went right up to the top of the hour, given all the questions that you had. So I appreciate all the interaction and everybody sticking with us and following along. And again, I'll stay on for another minute or two just to make sure I can get to as many of these questions as we can. But if you don't have any further questions, feel free to drop, and I appreciate everyone's attendance.